Alright guys, last video of the year, unless I do a review video. But in terms of notes, last note video of the year. Let's just recap when we use which triangles we use these laws for. When you have trig functions, that means you need a right triangle, right? Law of cosines is when you have all three sides, or when you have two sides and the included angle. Alright. Law of sines is angle, angle, side. We talked about that before the quiz. It was on the quiz. Angle, side, angle. And there's also the side, side, angle, the one that spells the bad word if you write it the other way. This one's the ambiguous case because sometimes if I give you two sides and then a random angle, you can have a few different things that happen. You can just have a one triangle when B is bigger than A. You can possibly have two triangles when B is smaller than A. Because the problem is that when B is smaller than A, the triangle could be drawn like this or like this, and we can either have an obtuse angle or an acute angle here and here for A, and you don't know which one it is because we don't give you enough information, so you have to work both of them. And there's also a situation where you don't even have a triangle. Okay, so steps to solving these SSA triangles. Just do what you normally do, solve for the missing angle using your law of sines. If for some reason it says there's an error, like you're taking an inverse sine of a number bigger than 1, then you have no triangles. It's not wrong, it just is there's no triangles. Then, if you do get an angle though, you definitely have one triangle. To check to see if you have a second triangle, just take the supplement of what you just found, which is 180 degrees minus what you found, and see if that also fits in the triangle. Because remember, your calculator for law of sines only gives you, or I'm sorry, for inverse sine only gives you an angle from 0 to 90. But it could also be an obtuse angle, and our calculator will never get that. So we have to try the 180 minus the angle you found and see if that also fits in the triangle. If it does, you will have two triangles to work with. If it doesn't, you only have one. So let's see this in practice. Example 1. I have an angle, or a triangle that says BAT. Angle B is that, angle 4 and 3. Alright, so here's what I have. I have some triangle BAT. Angle B is 34. Side A is 4. Side B is 3. This is the SSA or ASS one, whatever you want to call it, but just don't say that in class. And here we go. So we're looking at this and go, okay, well, I don't know how many triangles I have. I could have a second triangle over here. But, so for triangle 1, I'm going to solve for, well, there's only one thing you can solve for, and that's angle A. We have B over sine B, or you can do sine B over B equals sine over A. So I'm going to do sine of 34 all over 3 is equal to sine of A all over 4. You cross multiply, and you solve, and you do the inverse, and you get angle A is equal to 48 degrees. Or 48.21 degrees. Okay, so that is for sure one of the angles. We got an answer that works. But now we have to check. There might be this second triangle where the angle wasn't really 48 degrees, it was the supplement. So angle A could also be 180 minus 48.21. Because our calculator wouldn't have given it to us, and maybe it screwed up. So we get 131.79 degrees. Well, double check. If I go back to my original problem and put 131.79 as an angle there, does that add up to more than 180, or are we okay and we can still find the angle T and have an actual triangle? Well, hopefully you guys see that 34 plus this does not get us over the 180, so we do have a second triangle. So for triangle 2, everything is still the same. Angle B is still 34. Angle, or A and B are still the same. I'm just writing them here so you guys know these do not change. But what did change is angle A for this triangle is this. Okay? So, all we need to do now is find the missing pieces. Oh no, it says find T. Okay, well in order to find side T, which is over here, we need to find angle T. And hopefully you guys realize that angle T can be found in both cases because we have the angle, we have two of the angles. So, for triangle 1, angle T is equal to 180 minus the 48.21 minus the 34. Okay, over here angle T is equal to 180 minus 131.79 minus the 34 that was given in the problem. When you do that math, you get T is 97.79 degrees, or it's 14.21 degrees, depending on the triangle. So we now have angle T on both triangles, and now we could find side T on both triangles using law of sines again. So we could say sine of 34 all over 3 is equal to the sine of the angle we just found, 97.79, all over T. That's what I'm looking for. For this triangle, same setup, sine of 34 over 3 equals sine of, now it's 14.21 all over T. So there we go. Those are our two setups. Cross multiply and solve. So for this triangle, the two possible solutions for T are T can be approximately 5.315, and for this one T can be about 1.317 feet or units, whatever. I didn't give units on this, so units. Alright, number 2. Again, always start out with drawing your triangle. So I'm going to do that first. It's arbitrary where you put your pieces. Angle S is 13. S is 12. U is 60. Okay, find N. Well, first of all, in order to find N, again, I'm going to just start by solving this triangle. What's the one thing using law of sines I can find? Because this is an angle side-side, which is bad. We can find angle U. So the first thing I'm going to do is go sine of 13 over 12 is equal to the sine of U all over 60. When you cross multiply and solve this, you get that the sine of U is equal to 1.125. When you inverse sine this, you don't get a solution. You get an error. So there is no possible angle that, there's no way there's an angle there that fits. So that means that there's no triangle to even do the problem with. And again, you just have to just start solving it, and if it didn't work out, it didn't work out. Alright, 2 more. Angle CAR, or I'm sorry, triangle CAR. C is 58. Little c is 9.3, and r is 7.5. And it says find angle r. Okay, well that's really good because guess what? That's the only thing we can really solve for anyway using law of sines. We have side-side angle again. So I have c and c, I have r, and I want to find r. So really we only have to do one step here. We don't have to do all of the triangle. So I'm going to start setting up my problem. Okay, I cross multiply, and I get that for the first triangle, you do get a triangle, that angle R is equal to 43.15. Well, let's double check if there's a second one. So this is one of my answers for the problem. If there is a second triangle, in the second triangle, angle R is equal to 180 minus that. So when you subtract that, you get 136.85. And now you look, do we have a second triangle? Can 136.85 fit in for R? Well, hopefully when you see that if you plug that number in for R, that plus C go over 180, this cannot be a triangle. So that doesn't actually work. So there's only one answer to the problem. It is angle R is 43.15 degrees. And finally, last example. We got dog, D-O-G. I was going to make a joke about Snoop Dogg, but I think his name's Snoop Lion now, so won't even matter. 15 degrees there for D. Little d is 9. G is 14. And here we go again. We got side-side angle. We can't have that. Or we can have that. It's just we have to maybe have two triangles. So the first thing I have to solve for, and the only thing I have to solve for, is G, which is good because, again, the question is just saying find G. So that means I won't have to do as much work right now. My law of sines setup, sine of 15 degrees all over 9 is equal to the sine of G all over 14. You cross multiply and solve, and you get angle G is equal to 23.74. Now you need to check for triangle 2. In triangle 2, angle G is equal to 180 minus 23.74. So angle G can equal 156.26, which is pretty high. But look at this and see if it can also fit in your original triangle. Can I take this value right here and put it in for G? Well, we have 156 and 15, which gets us up to about 171, which is less than 180, which means that this second triangle is also possible. So my two answers for angle G are 23.74 degrees, or it could be 156.26. Okay? And then if I wanted you to solve for both triangles, all the missing pieces, you would just go out from there. And but you'd have to work both triangles. We'll probably do one of those together in class. All right. Well, that was it. You guys are done for the year with videos. I hope you guys enjoyed the videos. I hope you guys go back and look at them. If you're stuck on something for finals review, they're all up for you. And I enjoyed working with you guys this year. I will see you in class.